Now I am taking new topic, linear differential equation. See, any differential equation of the form. Now there are two forms. Any differential equation of the form dy by dx plus p into y equal to q. In this form, p and q, these are constants or functions of x only. P and q are constants or functions of x only. dy by dx plus p into y equal to q, this form. Or here I am putting another form, dy by, now see, now in this form I am replacing y by x and x by y. So dx by dy, say replacing y by x, x by y, plus p into x equal to q. So y is replaced by x is replaced by y is replaced by x. Here also I am replacing x by y, where p and q are constants or functions of y only. Functions of x is replaced by y only. So differential equation of the form dy by dx plus py equal to q, or dx by dy plus px equal to q, this is said to be, I am continuing on this side, it is said to be first order linear differential equation. So whenever we will find solution of given a differential equation, if you find a given differential equation of this pattern, then we will apply a method which now I am going to explain. Now to solve this differential equation, say here method to solve this equation, method to solve this differential equation. Here for such differential equation, first step is we find integrating factor. Find integrating factor. It is defined by integrating factor equal to e raised to integral of px with respect to x. First step to find its solution is find integrating factor if. It is equal to e raised to integral of this function with respect to x. In case of such differential equation, in this form, here a method to solve this equation is, first step is find integrating factor. It is defined as e raised to integral of, now say it is a function of y only, constant or function of y. So p is a function of y only, so we put here p dy. Here we can say p dx. P is already a function of x, so p dx, this is already a function of x, so we simply put here p dx, here p dy. After getting integrating factor, next step is, this was step 1, next step is we multiply this equation, multiply equation by integrating factor. So this equation will be multiplied by integrating factor, so it will be integrating factor means this value into dy by dx plus p integrating factor into p into y equal to integrating factor into q. So integrating factor into dy by dx plus integrating factor into p into y equal to integrating factor into q. That is next step. Similarly here we multiply equation by integrating factor. So here this will be multiplied by integrating factor into dx by dy plus integrating factor into p into x equal to integrating factor into q. So doing this, the immediate next step will be, this means this left hand side will be always d by dx of integrating factor into y. It will be always true, whatever will be here left hand side after getting equation 1 multiplying by integrating factor, this will be always d by dx of integrating factor into y. Here this left hand side will be always d by dy of integrating factor into x. And RHS keep as it is. Here we take RHS as it is, integrating factor into q. Then next step, integrating both the sides. Here we integrate both the sides with respect to x. Here we will integrate both the sides with respect to y, because here it was with respect to y. So multiply both the sides with respect to y. So here integrating both the sides with respect to x, integrating left hand side, integral of LHS will be integrating factor into y, and this will be integrating factor into q with respect to x. This side we are integrating with respect to y, so integrating factor into x, integrating d by dy with respect to y. So this number is equal to integral of if into q, this is with respect to y. and then integrating RHS with respect to x, putting integral on the right hand side, then in the next step we get it gives general solution. Similarly here, next step gives general solution. Now to understand this procedure, suppose I am taking one question. Question is, solve dy by dx plus 1 upon x into y equal to, suppose here I am taking only x, or we take x bar. Suppose this this equation is given. Now see, observe equation, identify type of equation, whether it is homogeneous differential equation or can we convert this directly into a variable separable form, or it is a linear differential equation. So the best way to identify whether a given differential equation is of this form or it is not, so method is, in given equation, if you find only one y, say look here only one y and dy by dx, so no y square, no y cube, no sin y, only y. It should not be as an inner function, no sin y, no cos y, only y. Then you can match with this form. So here only one y. So matching with that form, dy by dx plus this will be p. P is a function of x only. So this is function of x into y equal to q. So p and q are functions of x only. P and q can be constants, both can be constant, any one can be constant, both can be functions of x, any one is constant, other is function of x, anything can be. So here this is p. P is 1 upon x, q is x square. This is a linear differential equation of this form. So we are applying this procedure. To apply this procedure, p and q are required. So this is p, this is q. Now first step is integrating factor. Integrating factor is e raised to integral of p with respect to x. So integral of p is 1 upon x. So it is e raised to log mod x, and e raised to log mod x is modulus x. E raised to log mod x is modulus. E raised to log y is y. In this question, if condition is x more than 0, then modulus x will be equal to x. If no any condition here given, then also considering that part as positive, we will keep x. Because in this calculation we are working with arbitrary constant. Due to role of arbitrary constant, we can remove modulus if no condition given. So this is integrating factor x. After getting integrating factor, multiply equation by integrating factor. So this equation, that means this equation I am multiplying by integrating factor. I say it is equation 1. So multiplying equation 1 by integrating factor. So remember, whenever you perform this procedure, whenever you take values of P and Q, equation must be exactly in this form. Means with dy by dx, there should be nothing here. If anything is in multiplication, first of all you have to remove it, then start the procedure. So dy by dx, besides dy by dx, nothing. So multiply this equation by integrating factor. I am multiplying by x. This is integrating factor. Multiplying by x, x into dy by dx plus x into 1 by x, that is 1. X into 1 by x is 1 into y equal to x into x square is x cube. So this is done. Equation is multiplied by integrating factor. So I have written this step. Integrating factor into dy by dx plus integrating factor into p, it is 1, equal to integrating factor into q, it is x cube. Now next step, d by dx of integrating factor into y. So next step is d by dx into integrating factor into y. So in previous step, left hand side it will be nothing but value of d by dx of x into y. In every question this will happen. You can verify. See, x into derivative of y is dy by dx plus y as it is, and derivative of x is 1. So what is it? It is d by dx of integrating factor into y. It is equal to x cube. So that is next step. So I have written this step. I have written this step. Now next step is integrating both the sides with respect to x. Now I am integrating both the sides. Integrating both sides with respect to x. Integral of LHS is x into y. Integral of x cube is x cube dx. So that is this step. Now next step gives general solution. So next step, that is we put value of RHS. So it is equal to xy equal to x raised to 4 by 4. Integral of x cube is x raised to 4 by 4 plus c, where c is arbitrary constant. So it is general solution. We can put in better form. Implies we can show this as y in terms of x. So see, y is equal to dividing by x, so it will be x cube by 4 plus c by x. So this is required general solution. So I have explained this method in this question. Now see, here I have explained a question based on first type in a linear differential equation. Now this is second type, second form. So application of second form. So to apply this procedure, to identify this form, the trick is, in given differential equation, if you find only one x, means no x square, no x cube, no x with a sign, that is sin x, cos x, free x, this is free x, only one x, nowhere x is given. Here in p and q, these are functions of y only. So p and q includes y, no x. And here dx by dy, this is derivative, first order derivative, and only x, if you find in that equation, then this will be applied. So say, look this equation. In this equation, these are terms for derivative. Other than these terms, look other terms. In other terms, here only x. Say only x. So it may be possible that we can convert this in that form. After getting this form, that form, we will perform this procedure. So let me try to convert in this form. So first of all, what I do here, this number I am shifting on other side. So here y dx plus x minus y square dy equal to 0. So this means y dx, taking this number on that side, so y square minus x dy. Then now this y I take on this side, dy on this side. So dx by dy equal to y square minus x upon y. That is dx by dy is equal to y square by y is y minus this is x by y. Now see, we arrange in this form dx by dy, then next term we need with x. So here is x only, so shift this term on the left side. So dx by dy plus 1 upon y into x, it is what, x by y equal to y. And now you can see that it is of this form, dx by dy plus 1 by y into x equal to y. So here only x here. P and q are functions of y only. So here we require this p in calculation. So here p is 1 by y, q is y. First step is integrating factor. So integrating factor is integral of p. See, here we do everything with respect to y. So doing with respect to y. In last question here we did with respect to x. So it is equal to e raised to 1 up p is 1 upon y. So this is e raised to log y, and e raised to log y is y. We keep here log of modulus y. And as I told, we neglect modulus. E raised to log y is modulus y, and modulus y we take y. If no any condition given, consider positive. Because in these methods, there is a role of arbitrary constant. That's why we neglect modulus. So this is integrating factor. So integrating factor is, it is y. Now we multiply equation by integrating factor. So we multiply which equation? Not given. We multiply standard equation. This is standard form. This is standard form, dx by dy plus py into x equal to q of y. This is standard form. So multiply equation 1 by integrating factor. So now I am putting this step. Integrating factor, so y into dx by dy plus y into 1 by y is 1 into x equal to y into y is y square. So next step, now this step. This will be nothing but d by dy of integrating factor into x. Integrating factor is y into x. This is fixed. In every such problem, After multiplying equation 1 by integrating factor, next step will be always d by dy of integrating factor into y. It is equal to y square. Now next step is integrating both sides with respect to y. So here integrating both sides with respect to y, so integrating both sides with respect to y. So next step is integrating left hand side, it will be y into x equal to integration of RHS with respect to y, with respect to y. So I have written this step. Now next step gives general solution. So next step is y into x is y cube by 3 plus c. This is general solution. We can put this in better form, dividing by y. So x equal to y square by 3 plus c by y. So it is required general solution. So this is the procedure which we will perform in both forms of linear differential equation. So this method is very simple and easy in application. Now to solve this question, dy by dx plus 2 into y is equal to sin x. Say it is of this form, dy by dx plus p into y is equal to q. When there is only y in the equation, say here y alone, only y, no y square, no y cube, only y raised to 1. Then if equation is this form, then this will be functions of x only. So here p is 2, q is sin x. Functions of x only or constants. Here p is constant, q is sin x. So when such form is given, formula for integrating factor is e raised to p dx. So first of all, check form of given differential equation. It is exactly in that form. Here coefficient of dy by dx must be 1. Here no any other number should be there to apply this procedure. Dy by dx plus 2 into y is sin x. This is linear differential equation. So here p is 2 and q is sin x. So integrating factor is e raised to p dx. So it is e raised to p is 2. So this is e raised to 2x. So this value, now we multiply equation 1 by integrating factor. So multiplying equation 1 by integrating factor. In this procedure, always keep remember that before you take values of p and q, check whether coefficient of dy by dx must be 1. No any number should be with dy by dx. If anything is there, then first of all you have to remove that number. So after getting this form, start procedure. And to this equation we say equation 1. So to this equation we multiply by integrating factor. So integrating factor is e raised to 2x. So e raised to 2x into dy by dx plus e raised to 2x into 2y. So e raised to 2x into 2y, so 2 I am putting on this side, e raised to 2x into 2y equal to e raised to 2x into sin x. So equation 1 is multiplied by integrating factor. After multiply equation 1 by integrating factor, as we discussed in procedure, left hand side is always d by dx of integrating factor into y. LHS is always d by dx of integrating factor into y. RHS keep as it is. You can verify this. Say if you verify, what is derivative of this product? U as it is, derivative of y is dy by dx plus y as it is, and derivative of e raised to 2x is 2 times e raised to 2x. So what is it? It is d by dx of e raised to 2x into y. So always it happens. Next step is integrating both the sides with respect to x. So integrating both the sides with respect to x, integrating both the sides with respect to x, we have integral of LHS is this d by dx will be removed. So antiderivative of this LHS is e raised to 2x into y, and integral or antiderivative of RHS is integral of e raised to 2x into sin x dx. Now in the next step, to calculate RHS, we have to perform procedure for integration. To integrate such functions, we have to apply rule of integration by parts. So because this will be slight lengthy procedure, in this equation e raised to 2x into y equal to, suppose its integral is I plus c, where I is equal to e raised to 2x into sin x. So separate RHS, getting integral for RHS. Now to integrate this function, we apply u into v. So say e raised to 2x and sin x, which function we should take as u, which function we should take as v. So to choose u and v in proper order, we use this trick LIATE. Say here e raised to 2x is exponential function, sin x is trigonometric function. Trigonometric function sin x, exponential function e raised to 2x. Now look here sequence, which is on left side. This is on left side. So whatever is on left side, consider it as u. So this will be u and this will be v. For next step, to apply rule of integration by parts. So it is equal to sin x into e raised to 2x dx. So that is now u into v. So u as it is, integral of v, so e raised to 2x by 2 minus integral of box means bracket. In box what we put? We put derivative of sin x, derivative of u, integral of v, that is e raised to 2x by 2. So that is 1 by 2 sin x into e raised to 2x minus 1 by 2 cos x into e raised to 2x dx. Now once again we use rule of integration by parts in this step. So it is equal to 1 by 2 sin x into e raised to 2x minus 1 by 2, now in bracket applying u into v. So u as it is, integral of v is e raised to 2x by 2 minus integral, here bracket, close the bracket for this second step, second term, we are using this bracket. Now in this box, derivative of u, so minus sin x, integral of v, so e raised to 2x by 2. So rule of integration by parts we applied 2 times. So then next is, it is equal to 1 by 2 times sin x into e raised to 2x minus 1 by 2 into 1 by 2 is 1 by 4 cos x into e raised to 2x, then minus minus plus 1 by 2 and outer is minus 1 by 2. So minus 1 by 2 into plus 1 by 2, that is minus 1 by 4 sin x into e raised to 2x dx. Now look here, this is here, this part is repeated, and what is its value? Its value is I. So here we keep this term by, we replace this term by I. This is I. So therefore it is equal to 1 by 2 times, from these numbers I am taking e raised to 2x common. So sin x by 2 minus cos x by 4 minus 1 by 4 times I. Let me say this equation 3. So it is from 3. So this is value of I. Now this number we shift on left side. So on left side it was I. This is shifted on this side. So it is 1 by 4 times I is equal to e raised to 2x into sin x by 2 minus, here taking LCM, 2 sin x minus cos x by 4. So that is, this is 5 by 4 times I is equal to 1 by 4 e raised to 2x 2 sin x minus cos x. This 4 is cancelled. So I is equal to 1 by 5 times e raised to 2x into 2 sin x minus cos x. So now this value we substitute in equation 2. So putting in 2, we have e raised to 2x into y. E raised to 2x into y is equal to 1 by 5 times e raised to 2x into 2 sin x minus cos x plus c. Now we can express this in terms of, we can express this solution as y in terms of x. Y is a function of x. So for which we divide this equation by e raised to 2x. So dividing by e raised to 2x, y is equal to 1 by 5 2 sin x minus cos x plus c into e raised to minus 2x. So this is required general solution, which is required general solution, which is required general solution. Now next question. Cos square x into dy by dx plus y is equal to tan x. Say look this equation. Whenever any differential equation is given, if you find only y, no y square, no y cube, no y raised to 4, no root y, no cos y, independent only y, and in other terms there are functions of x, then it can be converted or it may be linear differential equation. So to get its standard form, if anything is besides dy by dx, remove that part. So to remove this part, we divide this equation by cos square x. So dividing by cos square x, dy by dx plus here sec square x, 1 upon cos square x is sec square x, y equal to tan x by cos square x, that is tan x into sec square x. So equation is divided by cos square x. Now dy by dx, this is now p, this is q. P into y equal to q. So here p is sec square x, q is tan x into sec square x. Integrating factor is e raised to integral of p with respect to x. So it is equal to e raised to, now p is sec square x. So it is e raised to, now integral of sec square x is integral of sec square x is tan x. Integral of sec square x is tan x. So this is integrating factor. Now we multiply. Equation 1 means this is equation 1. Multiplying this equation 1 by integrating factor, we get e raised to tan x into dy by dx plus e raised to tan x into sec square x into y equal to e raised to tan x into tan x into sec square x. So equation 1 is multiplied by e raised to tan x, e raised to tan x, e raised to tan x. So multiplied by integrating factor, and immediate next step is always d by dx of integrating factor into y. So whatever was left hand side in previous step, it will be always derivative of integrating factor into y. You can verify. Say look here, this is u, derivative of y is dy by dx, then y as it is, and what is its derivative? So e raised to tan x into sec square x. RHS keep as it is. Now integrating on both the sides with respect to x. So integral of LHS is, means antiderivative of d by dx is e raised to tan x into y equal to e raised to tan x into tan x into sec square x dx. Now here we require procedure to integrate this right hand side. So let me say its integral e raised to 10x into y is equal to, because on RHS we have to take help of substitute. Idea can be obtained from sec square x dx. If we take 10x equal to t, if 10x is t, then sec square x dx can be removed. So e raised to 10x into y equal to, here we say it is I plus c. We say it is equation number 2. Integral of right hand side is I plus c. So RHS is, or in this question you can continue by without taking I. Suppose I continue this as equal to, here we take 10x equal to t. Now taking 10x equal to t in RHS, taking 10x equal to t, sec square x dx equal to dt. 10x is t, so sec square x dx is dt. So right hand side of this equation number 2, therefore, so in equation 2, RHS is here e raised to 10x is t, 10x is t, so sec square x dx is dt. Now we integrate this function. Say here, this can be integrated using rule of integration by parts. We can also this integrate by this rule, e raised to x into f plus f dash. Its integral is e raised to x into f plus c. This can be integrated by two methods. Either you can integrate this by rule of integration by parts, or you can integrate by this rule. In this question I am using this rule. So say here e raised to t. Now here this number, I am splitting this t in such a way that one part becomes f, other part becomes f dash. Here I want f and here I want f dash. So what we do, first of all, whatever is given, keep as it is. We can't change value. So t as it is. Now if t is a part of f, then its derivative should be here. So derivative of t is plus 1. But we cannot change value. 1 is extra, that should be subtracted. So put here minus 1 to adjust the value. Now if we keep here minus 1, then here I should keep derivative of minus 1. So what is derivative of minus 1? 0. No need to put 0. Now look here, t minus 1 plus 1, it is what? It is t. So we have split up t as t minus 1 plus 1. So this becomes now f, and this is derivative of t minus 1. So it is e raised to x fx plus f dash x dx. So by this rule, its integral is e raised to x into fx plus c. So this is one method. And other method you can also do by rule of integration by parts, considering this as u and this as v. That is second method. So now putting back value of t, what is t? 10x. So e raised to 10x into 10x minus 1 plus c. T is 10x. So now this value we are putting in equation 2. So putting into e raised to 10x into y is equal to value of RHS is e raised to 10x into 10x minus 1 plus c. Now this can be expressed y as function of x. So dividing by e raised to 10x, getting solution in better form, y is equal to divided by e raised to 10x. Here you divide by e raised to 10x, so it will be 10x minus 1 plus c divided by e raised to 10x, so e raised to minus 10x, c into e raised to minus 10x, where c is arbitrary constant. So this is required general solution. Now next question, to solve this equation. See, in this equation, here there is y, here also there is y. So first of all, from these two terms I am taking y common, minus x, from these numbers I am taking y common, so plus 1 plus x cot x into y. See, 1y plus xy cot x, xy cot x. So from these two numbers y is taken common, and this minus x I am shifting on other side, so plus x. Now dividing this by x, dividing this equation by x, it is 1 upon x plus cot x into y equal to 1. And now you can see that this is dy by dx plus px into y is qx. Dy by dx plus p into y is q, only y. This is function of x, this is function of x. So this is linear differential equation. So in given equation, if terms are scattered, join them in such a way that you can get standard form. So this standard form was hidden in this equation. So now procedure, here p is 1 by x plus cot x, p into y equal to q. Q is 1. This is constant. Anyone can be constant, both can be constant, both can be function of x. So integrating factor, e raised to integral of p dx. So integral of, now p is 1 upon x plus cot x. This is p. So e raised to 1 upon x, its integral is log mod x plus cot x. Integral of cot x is log mod sin x. So applying here working rule of log, e raised to log mod log a plus log b is log a into b, and e raised to log y is equal to y. So this is integrating factor. It is integrating factor. Now we multiply equation 1 by integrating factor. So multiplying equation 1 by integrating factor, x sin x into dy by dx plus x sin x into 1 upon x plus cot x into y. Here x sin x is multiplied, here x sin x is multiplied. On right hand side, x sin x, 1 into x sin x is x sin x. So After multiplying equation 1 by integrating factor, next step is always d by dx of integrating factor into y. This is always the next step. You can verify this. See, u as it is, derivative of y, plus y as it is, and its derivative will be x as it is, derivative of sin x is cos x, and sin x as it is, derivative of x is 1. So here you will get same. See, product of these two numbers. Let me keep one more step. See, look here. X sin x into dy by dx plus multiplying this two, it is sin x plus multiplying this two, it is x cos x into y is x sin x. So next step is d by dx of, it is integrating factor into y equal to x sin x. See, you can verify this. U as it is, this is derivative of y, plus y as it is, and its derivative is sin x as it is, derivative of x is 1, here 1, plus x as it is, derivative of sin x is cos x. So next step is integrating both sides with respect to x. X sin x into y is equal to x sin x dx. So that is x sin x into y is equal to, now here rule of integration by parts. Look this trick, LIATE. Algebraic, x is algebraic function, sin x is trigonometric function. Trigonometric function is sin x. So x is on left side, sin x is on right side. This should be u, this should be v, and already in proper sequence. So applying u into v, u as it is, integral of sin x is cos x minus integral of box, in box derivative of x is 1 and integral of sin x is minus cos x. So rule of integration by parts. So it is equal to, therefore x sin x into y is equal to x cos x minus minus plus, and integral of cos x is sin x plus c, and this can be expressed in y in terms of x. So now I divide by x sin x, dividing this equation by x sin x, y is equal to, dividing x cos x by x sin x, x will be cancelled. So cos x by sin x is cot x plus sin x divided by x sin x, so it is 1 upon x plus c upon x sin x, c upon x sin x. So this is required general solution, where c is arbitrary constant, where c is arbitrary constant. Say here, next question, to find a particular solution of this differential equation. Say here, in this equation, in this place there is only one y. So whenever you find only one y or only one x, then think about a linear differential equation and its method. So doing accordingly, here the coefficient of dy by dx should be 1. So removing this part, I am dividing this equation by 1 plus x square. So dividing by 1 plus x square, 1 plus x square divided by 1 plus x square. This is the next equation. So now you can see that this is a function of x, this is a function of x only, this is y. So dy by dx plus px into y is qx, it is standard form. So here px is, or we say p is 2x upon 1 plus x square. This is p, or p of x, function of x. Integrating factor is e raised to integral of p with respect to x. So integral of 2x upon 1 plus x square, that is e raised to, now you can see that this is derivative of denominator, this is f dash if it is f dash upon f is log of modulus f dash upon f, integral of f dash upon f is log of modulus f. So it is 1 plus x square. So now we multiply equation 1 by integrating factor, multiply equation 1 by integrating factor, 1 plus x square into dy by dx plus, multiply second term. So 1 plus x square will be cancelled. So 2x into y equal to, multiply here by 1 plus x square. So it will be 1 upon 1 plus x square. After multiplying it by equation 1 by integrating factor, LHS will be always d by dx of integrating factor into y, and you can verify it in previous LHS. Say u as it is, this is its derivative, plus y as it is, and derivative of 1 plus x square is 2x. This number we keep as it is. Now integrating both the sides with respect to x, integral of LHS is 1 plus x square into y, and here 1 upon 1 plus x square, its integral. So therefore 1 plus x square into y is equal to, now its integral is simple, tan inverse x plus c. So therefore here y can be expressed in terms of x. So y is tan inverse x upon 1 plus x square plus c upon 1 plus x square. This is general solution. Whenever we are asked to find a particular solution, first of all we always find general solution. Now to find a particular solution, we use given condition. Now we are putting y equal to 0 when x equal to 1 in general solution. So here y is 0, x is 1, here 1 plus 1 is 2, plus c upon x is 1, so 1 plus 1 is 2. So therefore 0 equal to tan inverse 1 is pi by 4 by 2, that is pi by 8 plus c by 2. Therefore c by 2 is equal to minus pi by 8. So c is minus pi by 4. So putting in general solution, y is equal to tan inverse x upon 1 plus x square. Now c is minus pi by 4 upon 1 plus x square, that is 1 plus x square. So put in better way. So this is required particular solution. It is required particular solution. Now next question. Find the equation of a curve passing through the point 0, 2. Suppose this is a curve which is passing from 0, 2. Given that sum of the coordinates of any point on the curve, suppose xy is any point on the curve, and here sum of coordinates, that is x plus y, it is sum of coordinates, exceeds, this value exceeds the magnitude of the slope of a tangent. What is magnitude of slope of tangent? See, this is tangent at xy. Its slope is dy by dx. So this is magnitude of tangent, magnitude of slope of tangent at point xy. So now see, look what is given. Sum of coordinates of any point, that is, this is any point. So sum of coordinates, that is x plus y, on the curve exceeds the magnitude of slope of tangent. Magnitude of slope of tangent, that means this value. This is magnitude of slope of tangent. Now this exceeds magnitude of slope of tangent to the curve at that point by 5. So this is more. This is 5 more. So to join these values by sign of equality, we should put here plus 5. So here this is differential equation. It is obtained from this statement. So we solve this equation. To solve this equation, putting this in standard form, dy by dx, y I am shifting on other side, so minus y equal to x minus 5. Let me say this is equation 1. So here p is minus 1 and q is x minus 5. So integrating factor is e raised to integral of p, that is e raised to minus 1 dx. Minus 1 dx. So e raised to minus x. This is integrating factor. Now we are multiplying this integrating factor to equation 1. So multiplying equation 1 by integrating factor, say here e raised to minus x into dy by dx, this is multiplied, minus e raised to minus x into y equal to e raised to minus x into x minus 5. So equation 1 is multiplied by integrating factor. So this left hand side is d by dx of integrating factor into y. This is always true. After multiply equation 1 by integrating factor, LHS will be nothing but derivative of integrating factor into y, and you can verify it. So u as it is, derivative of y, plus y as it is, and derivative of e raised to minus x is minus e raised to minus x. Now integrating both the sides, with respect to x, antiderivative of LHS is e raised to minus x into y equal to e raised to minus x into x minus 5 dx. Now to integrate on the right hand side, we use rule of integration by parts. Now which function should be taken as u, which should be taken as v? So always remember this trick, LIATE. E raised to minus x, it is in this group, exponential function, and x minus 5 is in this group, algebraic function. So this should be taken as u and this should be as v. So changing this order, u into v. Now u as it is, integral of v, its integral is e raised to minus x upon minus 1 minus integral of box. Now in box I put derivative of u, it is 1, and integral of v, so it is e raised to minus x upon minus 1. So this is here. Now I am including minus 1 in this bracket. So 5 minus x into e raised to minus x, minus minus plus e raised to minus x dx. So it is 5 minus x e raised to minus x, and again its integral is e raised to minus x upon minus 1 plus c. So therefore e raised to minus x into y is equal to, we have obtained 5 minus x into e raised to minus x minus e raised to minus x plus c, where c is arbitrary constant. Now this solution, it can be expressed in terms of y, it can be expressed y in terms of x. So dividing by e raised to minus x, this will be removed. Here divide this by e raised to minus x, this will be removed. Divide this by e raised to minus x, so minus 1, plus divide by e raised to minus x, so c into e raised to x plus x. That is y is equal to 5 minus 1 is 4, minus x keep as it is, plus c into e raised to x. So this is general solution. It is general solution. It represents family of curves satisfying this condition. But we are asked a particular member from this family, and for that condition is given that required curve is passing from 0 to, this is particular condition. So required curve passes through 0 to, so using this value, putting here y equal to 2, x 0, so 4 minus 0 is 4, plus c into e raised to 0 is 1. So value of c is minus 2. So this value we are putting this in equation number 2. So putting into y is equal to 4 minus x minus 2 into e raised to x. So which is required equation, of curve.